It's morning, and in they come. Millions of people headed for work. It doesn't take an expert to spot a fundamental weakness in our primary transportation system. Car after car, designed to carry 4 to 6 people with only the driver. In fact, over half of all passenger car trips are single occupant. Very inefficient use. There was a time when crowded streets and highways were not a serious problem, before the screams from Washington for mass public transit to replace cars. When the use of gasoline was not a vital national concern, back when gas was cheap and plenty. But now, things are different. And the question is there a more efficient way? The answer is yes, there is another way. This is the Lean Machine, developed jointly by GM engineering staff and design staff. A vehicle designed for all those single-occupant trips. The Lean Machine is ideal for driving back and forth to work. It's perfect for a trip to the local beauty salon. A practical vehicle to drive no matter what the weather. It's a low-cost addition to existing personal transportation. It's ideal just to get around in and to enjoy. The Lean Machine could relieve traffic congestion because it takes up so much less room on the road than conventional cars. In fact, 2 can travel side by side on a single lane. Because of its small size and weight, it's remarkably fuel efficient, with mileage projected up to 200 miles per gallon. It is exceptionally maneuverable and easy to park. Its small size helps relieve parking congestion. All in all, the Lean Machine is simple, practical, economical, a new concept in personal transportation. Not an automobile, not a motorcycle. It's something entirely different. In fact, the Lean Machine is the only revolutionary new road vehicle developed in this century. The secret to the Lean Machine's extraordinary potential is its unique leaning concept. Leaning into turns is a basic natural reaction. It is essential to maintain balance while turning. A good example is a baseball player rounding third base. The faster the turn, the greater the lean. There are principles of physics that explain this, and they have been applied to this unique new vehicle.
For a number of years, we've been trying to come up with an efficient single-occupant vehicle. One that was highly maneuverable, simple and lightweight, one that makes the smallest, cleanest hole in the atmosphere, one that occupies the least space in parking, maneuvering, and required no more than half a lane on our streets and freeways. Not a motorcycle, but an enclosed vehicle that would be comfortable in any kind of weather. The basic and fundamental problem with very narrow-base vehicles is stability and control, balance and maneuverability. The side forces generated in turning make it want to fall over. This is a problem common to anything that moves. Except for things like turtles and snakes, nature's solution was to provide for weight transfer by leaning or cambering into the turn, but with at least 2 laterally displaced feet on the ground for balance. That's why a horse has 2 in front and 2 in the rear, instead of 1 in the front and 1 in the back like a bicycle. What we're really trying to do is to come up with a way to lay the guy down so he can make a nice, neat hole in the atmosphere, lean into the turns, but keep both feet on the ground for balance.
Let's take a look at several examples to help explain balance. An unsupported broomstick is unstable and will fall over. The same broomstick in the palm of your hand can be kept in balance by continually moving the base in the direction of the fall. As applied to vehicles, that's the way you keep your balance on a unicycle. You steer or pedal in the direction of the fall. A bicycle with its long wheelbase is stable longitudinally, but not laterally. Once moving, the bicycle can still be balanced, but only with constant steering inputs. But at rest, it has no stability. An ice skater on one skate has the same problem. At rest, he is unstable. But with forward velocity, he can steer and balance. When he makes a turn, he must lean to counteract the centrifugal force. But like the cyclist, he must also maintain balance by constantly steering his skate in the direction of the fall. On both skates, he becomes stable, even at rest, because he can then shift his weight from side to side. He does not have to steer to maintain balance. By spreading his legs far enough apart to counteract the centrifugal force, it's possible for the skater to turn without leaning, but it's unnatural. A conventional car remains upright the same way, by a wide stance or track. But it's wider than necessary for a single occupant. For maximum maneuverability, the skater narrows his stance and leans into the turn. A rigid tricycle, like the skater on 2 skates, is stable at rest, but in a turn without a wide stance, it falls over. Now, let's see how these principles apply to this new vehicle concept. This vehicle is stable at rest, but unlike the tricycle, it can maintain balance while turning. Like the skater, this machine lets you effectively keep both feet on the ground. Like the bicycle, it's maneuverable in motion because it can lean into turns. That's the lean machine. Narrow, yet easily stabilized under all conditions, allowing him to lean into the turn and balance the vehicle at all attitudes. Operation of the lean machine is simple and natural. With foot pedals to control the lean, it becomes an extension of the driver's body, leaning with him, responding to his touch. The result is an extraordinary ability to maneuver, to move in and around tight places, to avoid obstacles. A sensible approach to safety, avoidance, like preventative medicine. This extensive investigation started by observing the natural human act of walking, running, and changing direction. This led to a study of weight transfer mechanisms and a variety of experimental vehicles that leaned, yet kept the driver's feet effectively on the ground, providing balance. Step by step, the R&D work continued. When a practical mechanism for leaning and balance was fully developed, and the engineering design layout was established. GM design staff began work on packaging and appearance. Like a typical car program, idea sketches were evaluated for direction. Then, full-size layouts were developed to package the driver and components. Scale models were generated for visual evaluations as well as preliminary wind tunnel tests. Full-size renderings were made to help establish the final look. After this, a full-size clay model was constructed to help finalize the design. As the model developed, it was subjected to wind tunnel testing. It had to be aerodynamically outstanding because fuel economy was a key objective. Wind tunnel tests showed where refinements were needed. The latest test results indicated the lean machine has less than 1/8 the aerodynamic drag of a conventional car. There are, of course, engineering refinements to be made and more running models to be built. There are also other designs to be explored, including front drive versions, but the basic principles have been proven. The result will be an exciting new vehicle for personal transportation, not a substitute for the family car, but a unique, simple, economical, pleasurable vehicle for basic personal mobility. And it can mix well with today's traffic and even better with tomorrow. The Lean Machine, another way GM can help meet the world's changing transportation needs.